All right, welcome to The Explainer. Today, we're diving deep into what's being called the AI gold rush, and we're going to go way past the usual headlines, the ones about sentient robots, and really get into the nuts and bolts. We're talking about the actual economics, the real-world industrial supply chain that's being built around artificial intelligence right now.
And calling it a seismic shift isn't just hype. You've got investment managers, you've got technologists. They all agree this is one of those huge foundational changes. Think about it. It's like the internet or globalization. It's the kind of thing that doesn't just create new industries, it completely rewrites the rules for all the old ones. So here's how we're going to tackle this. We're going to follow the AI value chain, from the ground up. We'll start with the raw materials, what we're calling the high price of power. Then we'll get a peek inside the AI factories, see how intelligence gets packaged and sold, and then, and this is a big one, we're going to stress test that whole bigger is better idea with some real data. And of course, we'll wrap up by looking at where this is all headed.
All right, let's jump right in. The very first thing you have to grasp is just how massive this moment is. Seriously, this isn't just another tech trend. People who know are seeing this as a fundamental reordering of the entire economy.
Okay, think of it this way. Remember how the internet created totally new ways for us to connect and, do business? AI is doing the same thing, but for intelligence itself. It's creating new ways to generate insights and automate really complex tasks. So for the companies that can figure this out, that can actually build and apply this tech, the opportunity is, it's absolutely massive. It's a brand new frontier, and everybody is racing to stake their claim.
But here's the catch. This new gold rush, it has an incredibly high barrier to entry. I mean, building a leadership position in AI isn't cheap. It requires some very specific and, very expensive raw materials.
It really all boils down to these three things. First, you need an almost unimaginable amount of computing power. We're talking warehouses full of servers. Second, you need the absolute top-tier talent, the researchers and engineers who actually know how to build and train these incredibly complex systems. And third, you need data, vast amounts of proprietary data to feed your models. You put those three pillars together, and you can see why this creates a huge advantage for the biggest, most well-funded companies out there.
And really, at the very bottom of this entire stack is raw computing power. We're talking about the semiconductors, the GPUs, those massive data centers. This is the bedrock. You simply cannot train a cutting-edge AI model today without access to a staggering number of these specialized chips. They are quite literally the digital pickaxes and shovels in this new gold rush.
And this flow creates a really clear value chain, almost like a factory assembly line. It all starts with the semiconductor companies. They're like the mines, digging up silicon to create the chips. Then you've got the infrastructure players who build those chips into massive cloud factories. On top of that, you have the application companies building the useful tools, which are then finally sold to end users in the market. That's us, individuals, big corporations, you name it.
Okay, so to really see how this all comes together, let's go inside one of the most famous AI factories out there, OpenAI. I mean, their story is just a perfect case study of the intense pressures and the big strategic pivots that are happening all across the industry.
OpenAI started with this really noble, idealistic mission, right? It was a nonprofit, and the goal was to develop AGI safely and openly for all of humanity. But then, they slammed headfirst into the harsh reality of those three pillars we just talked about. The cost of computing power was just astronomical. So to compete, they needed capital. And not just a little bit, a lot of it. This is what forced them to create that unique capped profit structure. It was a clever move that let them take on massive investments, like that $1 billion for Microsoft, while trying to hang on to their original mission. And wow, nothing illustrates this shift more starkly than their stance on openness. The original promise? Complete transparency. They were going to share their code, their papers, their patents, everything. But as the stakes got higher and the competition got fiercer, that ideal started to buckle. Their own charter now basically says they might have to clam up and reduce publishing to protect their work. It's the core tension of the entire industry, right there in black and white. The founding ideals of open collaboration clashing with the cold, hard reality of a competitive arms race.
So that whole struggle at OpenAI, that desperate need for a business model that can pay for these immense costs, it really begs a bigger question. Once these incredibly expensive and secretive models are actually built, how do they get to the market? How are these companies actually making money from them?
Well, the dominant model that's emerged is something called AI as a service, or AaaS. You've probably heard of SaaS, right? Software as a service. This is pretty much the same idea. Instead of you having to buy and manage your own multi-million-dollar AI infrastructure, you can just rent it. You get access to these super powerful AI capabilities right through the cloud. It's what makes the technology accessible to a much, much broader range of businesses.
And inside this AI as a service world, we're seeing four main strategies pop up. Let's start on the top left. You've got your model-focused products. Think of something like Perplexity. Their bet is that they can win just by having a super slick, easy-to-use product. Right below that, you have embedded services, like a company called Harvey. They're more like consultants, partnering up with their clients to co-develop custom AI solutions. Now, if you look at the right side, this is where things get really interesting. You have outcome-focused companies. They don't just sell you a tool, they sell you a finished result. We will translate your website perfectly, guaranteed, that kind of thing. And finally, in that bottom right corner, you have this fascinating roll-up model. This is where a company buys a traditional business, say a law firm or a call center, and then just injects AI into it to make it radically more efficient from the inside out.
Okay, so for the last few years, the race has been all about one thing: scale. Build bigger and bigger models, cram in more parameters, train them on more data. But that raises a really critical question. Is bigger actually better? Because, this pursuit of scale eventually hits a wall. It's a concept called diminishing returns, where every extra dollar you pour in gets you less and less of an improvement. Let's actually look at the data.
All right, now this slide right here gives us some fascinating hard data on those diminishing returns. Just look at the chart. Going from a $10 million model to a $100 million one. Yeah, that's a 10x cost increase. But you get a pretty decent performance boost on this programming task. But then, look at that next jump. To get just a little bit better, the projected cost explodes to $1 billion. The price tag for each tiny improvement is just skyrocketing.
And this chart, wow, this brilliantly illustrates that the industry is paying attention. For a decade, the computing power used to train the biggest models went almost straight up. I mean, an exponential explosion. But now, look at it. That curve is clearly starting to flatten out. That explosive growth is slowing down, and it's because companies are realizing that just throwing more and more money at the problem is no longer the winning strategy.
And here it is, the crucial point. Developers are literally voting with their downloads. On Hugging Face, which is a major hub for AI models, the smaller, more efficient ones, those with under 1 billion parameters, which you can kind of think of as the model's horsepower, they're getting downloaded hundreds of millions of times. And the giant, state-of-the-art models, just tens of thousands. The market is sending a really clear signal here. People want models that are cheaper, faster, and easier to run for their specific tasks.
Okay, we've just walked the entire value chain, all the way from the silicon mines to the screen in front of you. So what's the big takeaway from all this? What does the future of the AI industry actually look like?
All right, let's pull all this together. What are the key things to remember? Number one, the AI economy is a real supply chain. It's not just about code. Number two, the insane costs are forcing even the most idealistic companies to become secretive. Number three, we've hit that wall of diminishing returns. Bigger is not automatically better. 4, the market is practically screaming for AI that's good enough but also fast and cheap. And all of this leads to maybe the most important point of all. The winners in this space might not be the ones with the absolute best tech, but the ones with the smartest business model.
Which brings us right to this final big question. Is the future of AI going to be dominated by the companies that build the biggest power plants, these massive general-purpose AIs that just generate raw intelligence? Or will the real winners be the ones who invent the most useful appliances, those smaller, specialized, and incredibly useful tools that solve specific problems for millions of people? That right there is the strategic choice that's going to define the next chapter of the AI revolution.